Hello friends, welcome to this video series on arithmetic. In this session, we'll see some differences between simple interest and compound interest. In the previous session, we had seen some basic properties and definitions of the same, along with various illustrations. In this, we will build upon those concepts and move forward. So let us see example 1. It says that find the difference between the simple interest and compound interest accrued in the second year on a principal of rupees 32,000 at 5% per annum, right? So that is what is given here. Now let us see. Here we'll see a shortcut also that I had tertiary discussed in the first session, but let us see first method 1. The difference between SI, and we know that simple interest in the first year is same as compound interest in first year, so no difference. Now SI in second year will be what? And that remains same, SI as same first year, and that will be 5% of 32,000, which is nothing but 1600 rupees, right? 1600. And CI2 will be what? We know that CI2 will be 1 plus R times CI1. This property we had seen in the previous session. Compound interest during a year is 1 plus R times the compound interest in the previous year. So here we can write this as 1.05, R means 5%, 0.05 into CI1. CI1 is what? That is R percent of P, which is 5 by 100 into 32,000, which is 1600, right? So 1.05 times CI1, which is 1600. So this, if we calculate, it will be I think 1680. 1.05 into 1680. 1680, right? So what is the difference between the simple interest and compound accrued in second year? So we had to find the CI2 and SI2, that is 1680 minus 1600, that is 80 rupees is the answer. From here we will also derive a generic expression. Now let us see what is there. We know that CI1 is equal to SI1 and CI2 is 1 plus R times CI1, and CI1 and SI1 is what? R times P, right? Principal. R is in fraction, right? So if it's 5%, 0.05 into P. So this we can further write as 1 plus R times R into P, right? And SI2 will be same as SI1, which is R times P. So if I see, take the difference between CI2 and SI2, this will be what? This equation 1 minus 2. So that is 1 minus 2, that is nothing but Rp plus R square P. I am expanding this first equation, R square P minus second square equation is Rp. So this gets cancelled. So therefore, if I represent it by delta, delta means difference between compound and simple interest for the second year is nothing but R square times P. This is a standard relation also. This we can remember also, or else we can solve using method 1, or we can remember this relationship wherein we will just put in delta for the second year, that is difference between compound interest and simple interest for the second year will be r square into p. Now here if I put r square is nothing but 5%, that is 0.05 into p is 32,000. So if I solve this, so this becomes point 25 into 32, so this is 80 rupees, right? Same as what we had got here. Now another approach similar only, but just a different representation, and this will be a very useful also, not may not be as useful for finding the solution to the questions where difference for the second year is asked, but certainly very much helpful when the difference for the third year we will calculate going forward. So let us see what happens. Here r is given as 5%, right? R is 5%, which is 5 by 100, which is 1 by 20, and time is 2 years, right? I mean time we are referring to 2 year, second year. So let us assume principal is equal to this denominator, that is, let it be denominator, that is d, right? So d raised to power t, right? D raised to power t, that is what we will assume. So this becomes, this is 20 raised to power 2, 20 is the denominator here, 20, and t is 2. So this is what we have assumed the principal to be. Principal is 20 units, right? So now if we see, we know that if we, for simple interest for first year and the second year, the simple interest will be what? For the first year it will be 1 by 20 r percent of 20 square, 1 by 20 of 20 square, which is 20 units. And for second unit also, second year also, it simple interest remains same, 20. Now for compound interest, we know that compound interest for the first year is again 1 by 20 of 20 square, which is 20. Now for second year, it will be 1 by 20 of 20 square, that is fine, 20, and again over this 20 again 1 by 20. So that becomes 20 plus 1, which is 21, right? So total here is 40 units, and here it is 41 units. So the difference becomes 1 unit difference between CI and SI, right? Or for the second year the difference is 1 unit, right? And here we know that this principal we have assumed as 20 square, which is 400 units, and that represents 32,000. So we have to find what is the 1 unit represent. So that will be 32,000 upon 400, which is 80. Sorry, this will be in rupees. Rupees 80 is the answer. This may appear to be a bit tedious, uh, and you may feel that using this formula may be much easier to solve. That is fine, but this method we should know, but this is just a very, I mean, important trick which will come very handy if we solve questions based on the difference of the third year, right? So that is what here what we have done. The trick is that we should assume the principal as a denominator, this rate denominator of the rate percentage raised to power the time, right? And then we can calculate the respective simple interest, compound interest, and that way, right? Let us move to question number 2. If the difference between CI and SI at the end of second year on the same principle is 12,000. So here method 1, the difference between second year, it is, we know that what r square into p, right? And r is given as 11%, 11.11%, which we can write as 1 by 9. In percentage we have seen this, we can write as 1 by 9. So delta 2 will be nothing but 1 by 9 square into p, and this delta 2, that is difference between the simple and compound interest for the second year, is given as 12,000. This formula we had seen in the previous illustration. So from here we can say that p is nothing but 81 times 12,000, which is nothing but 9,72,000. This is the answer to this question. Or using the method which we just saw, method 2, here r is 11.11%, which is nothing but 1 by 9, and time is 2 years. So from these two we will assume that let the principal be 9 square units, right? So from then further we can say that simple interest for the first year and the second year, and compound interest. So simple interest for the first year will be what? Principal is 9 square and rate of interest is 1 by 9. So 1 by 9 of 9 square, that is 9 units. Then for the second unit year also the simple interest remains same, 9 units. Compound interest will be what? Compound interest will be for the first year same, 9 units, and second year it will be 9 plus 1 by 9 of this 9, right? Interest on interest. Interest during first year is 9, so 1 by 9 of 9 is 1 unit, so this becomes 10. So total here it is 18 and this is 19. The difference between the second year is just 1 unit, 1 unit, right? And this difference is given as 12,000, and this 1 unit represents rupees 12,000. So principal we have to find, which is 81 units. 81 unit will represent 12,000 into 81, which is 9,72,000. Just another way of solving, right? Another way of solving, nothing else. This we will keep in mind. Now let us move to question 3. If the rate of interest is 8%, what is the ratio of the total CI and SI earned in the first 2 years, assuming that the principal is same, right? So let us again derive this first. Simple interest, compound interest, uh, rather let us let the principal is equal to P0, rate is equal to R, right? So now we can say that simple interest, and this is 1 to time. So simple interest during the first year will be what? R P0, and again same R P0. Better we'll denote this with P only, right? And now compound interest for the first year will be same R into P. For the second year the compound interest will be R P plus again interest on interest, interest on the interest of first year, which is R percent of RP, which is R square P, right? Now if the rate of interest is 8%, what is the ratio of the total CI? So total CI and SI, here the total becomes 2RP, and here it becomes 2RP plus R square P. So the ratio of CI to SI is 2RP plus R square P upon 2RP. So this basically becomes 1 plus R by 2. Ci by Si is this. This is a very standard also. This we can remember. Otherwise, it takes hardly few seconds to derive this. We need not do. So now using this, if we solve uh, that, now only variable is r, and r we have been given 8%. So from here we can say that Ci in the and this is just remember for 2 years only. Ci2 upon Si2. So Ci2 upon Si2 will be 1 plus r is 8%, which is 0.08 by 2. So this becomes 1.04. In ratio terms, we can write as 104 by 100, which is 4 times this will go as 426 upon 25. So the ratio becomes 26 is to 25 answer, right? So pretty simple, nothing else, just this derivation was important, and even the derivation was quite easy, right? So now we will move to the next question. Here it says that if the ratio of total CI earned in the first 2 years to the total SI earned in the first 2 years is 9 is to 8. So that we know now that CI in 2 years upon SI in 2 years, this is not during 2 years, this is total in 2 years, is given by 1 plus R by 2, which is given to us as 9 by 8. From here we can say that R by 2 is equal to 1 by 8. So that means R is equal to 1 by 4, which is nothing but 25%, right? So another simple problem. Now let us see, if the rate of interest is 16.67% and the final amount after 2 years is 2,40,100, then find the principal amount and the difference between SI and CI. So again, any method we can take. Let us take the unit method. So here R is given as 16.67%, which is nothing but 1 by 6. In percentage we have seen this 1 by 6. How to get this? 16.67 upon 100, and then that becomes 1 by 6. And time is 2 years, right? So from here let us assume that assume principal original principal is nothing but this denominator 6 raised to power time square, 6 square units, right? So now it is given that, and that time be denoted on this axis, first year, second year, and simple interest, compound interest. Simple interest will be what? 6 square unit into 1 by 6, so 6. Compound interest for first year is again 6. For the second year it will be what? Principal into R, 6 square into 1 by 6, which is 6, plus 1 by 6 of the interest earned during first year. So 1 by 6 of 6 is 1 unit. So this is 12 and this is 13, right? So and now here one more thing, final amount, let us add at compound interest after 2 years. So now final amount will be what? Principal plus CI, which is 36 plus 13 is 49 units, right? So 49 units represents 100, and the difference between CI and SI is 1 unit. 1 unit. So 1 unit will be 2,40,100 upon 49. So I think 49 square is 2401. So this becomes 4900. So the difference between ci and si directly we obtained as 4900, right? So this we can write as delta 2 as a, and then we have to find the principal also. Principal is 36 units, so 36 units will be 36 into 4900. So 36 into 49 will be I think 176400. So this is the principal amount. So therefore we have obtained the answer to this question. Or we can do one, I mean, using the generic method also we can do. I mean, we may note that this method 1 may not be very suitable in case of the difference for the 2 years, right? So in that case we should go with the generic method only. Here R is 16.67%, which is 1 by 6, right? Time is 2 years. So we know that at compound interest amount is nothing but principal into 1 plus R raised to power 2, right? And this is given as 2,40,100. From here we can calculate P as again 2,40,100 into 36 upon 49. I expanded this as 7 by 6 square. So this will be nothing but 1,76,400. So principal we have obtained. So therefore now we can solve the difference also. What is delta S2 is nothing but R square into P. R square is 1 by 36 into 176,400. So that we will divide 176,400 divided by 36 is 4,900, right? So this is 4,900. So this may be a tad easier and less time consuming. So this is a preferred method in case of difference of SI and CI for 2 years, right? Now if the again next question says if the rate of interest is 10% and total CI after 3 years. Now the question on 3 years is coming. So 3 years is 13,240. Then find the difference between SI and CI. So here R is 10%. This we can write as 1 by 10, right? And time is 3. So from here we can say we can assume principal to be what? The denominator 10 raised to power time 3. So 10 raised to power 3 units. Time axis and then simple interest and compound interest. 1 year, 2 years and 3 years. Simple interest will be what? 10% of 1000. So that is 100, 100 and 100. Simple interest remains same for all the years. Then compound interest. For first year it remains same as simple interest, that is 1 by 10 of 1000, 100. Then for second year it will be 100 plus 1 by 10 of the CI during first year, which is 10. And for third year CI will be what? 10% of 1000 units, which is again 100, plus the interest during the previous period, which is 110. So 10% of 110 is 11, right? So basically this is nothing but is equal to 100. This is 110. No, say here. Uh, During third year it will be 100 because principal into R, 1000 into 10% is 100. Then interest on interest for the first period, which is 10. Then plus interest on interest for the second period, which is 110 का 10% is 11. So here it becomes 121. This we know that this will be nothing but 1.1 times 1.1 times. So the total here is 300 and total here is 331, right? So we can say that, and it is given that total CI is, it means that 331 units represents 13,240 rupees. So we have to find the difference. Difference is 31 units. So 1 unit will denote 13,240 upon 331. This is, I think, 4 times it will go 40 rupees. So 31 units. 31 units is the difference between the two. Difference is 31 units. Difference for 3 years. So 31 units will represent 31 into 40, which is 1240. From here we can again write a generic formula also, that difference between simple interest and compound interest after 3 years, that is delta 3, will be given by 3a plus 1, where a is denominator of a rate of interest when expressed in, or we can say 3d plus 1, we have used d, where d is the denominator in 1 by d form, right? So 3d plus 1. So here we could have directly written using this formula that difference of the 3 years will be nothing but, here d is 10, so 3 into 10 plus 1, which is 31 units, right? And we know that 31 units we have to find. So I mean, this part, this middle part we could have avoided simply, right? Middle part we could have avoided simply. So this is the standard result which we can remember also. Now you would be wondering ki what would happen if we go by the generic approach. That would also that can also, I mean, help us get to the answer, but that will be a bit tedious, so that I'm not discussing. Otherwise you may write the formula and derive this, because we know what would be the cases here, right? We know, or maybe in the next question I'll try that. So here question 7 says that if the rate of interest is 50 by 6%, so 50 by 6% means 50 upon 600. So this means 1 by 12. And the difference between the CI and SI after 3 years is 9250. So delta 3 we know is 3D plus 1, which is 12 3 are 36, 37 units. And 37 units denotes 9250. So we have to find the principal amount, right? And principal we can assume this to be 12 3. Here time is 3 years. So 12 3 units, 12 raised to power 3 units. So 1 unit here will represent 9250 upon 37. So I think this will be 37 to ja 74, then it 18, 37 5 ja. So I think it is 250. Yeah, 250. Right. So 250 rupees. So 12 cube is 1728 units. So 1728 units will denote 250 into 1728, which is 4 lakh 32,000. I just simply multiply this 1748 by 4, so I can get this 000 answer. So this is using the formula which we saw on the previous question. Now I try with the generic approach also. Now see, it is given that, let us assume it is principal is P, rate we have been given as 1 by 12. So we can say that CI, sorry, SI will be what? I mean, generic terms we can write here. First year, second year, third year, RP, RP and RP. And then for compound interest, it will be RP. This will be RP into 1 plus R. And again for third year, it will be RP into 1 plus R whole square. Right. So now if we add this is 3 RP, and here it becomes RP 1 plus 1 plus R plus 1 plus R square plus 2R. So this is 3 plus 3R plus R square, right? So now if we see the difference, CI3 minus SI3, it will be 3RP plus 3R square P plus R cube P minus this 3RP. So that is nothing but 3 times R square P. I will take common 1 plus R, right? So this is the delta 3, which is a bit I will say a bit tedious, but anyway, here also if I substitute the value of R as 1 by 6 and P as uh, I mean here delta 3 has been given 9250, we can get the value, but this actually is a bit, I mean, cubic equation, so may not be very easy. In this question this will not be useful, because again we'll have to solve a cubic equation, which will be very time consuming. Otherwise, had the question been wherein R and P would have been given, then delta 3 we can just find by substituting the value, right? So this is method 2, I mean approach 2 we can take in certain cases. However, this approach, method 1, is very, I mean, useful in such cases, right? This 3D plus 1, 3D plus 1, we have to remember this. Now again one more question I will take on this. If rate of interest is 12%, that is a rate of interest is 12%, this I can write as 12 by 100, which is what, 3 by 25. So this I have to write as 1 by D form. So this I can write as 1 upon 25 by 3, right? So here D becomes 25 by 3, and then time is 3 years. After 3 years, so here I will say let's assume principal, assume P is equal to nothing but what, P is equal to D raised to power T. So D is 25 by 3 raised to power 3. This I have assumed. Now we know that delta 3 is nothing but 3 times d plus 1. Straight away we will not calculate that. So 3 into d is 25 by 3 plus 1, which is 26. So 26 units. Difference has been given as 2106. So 1 unit will represent 2106 upon 26. Let me see if it's 2106 upon 26 is 81 units. So this gives 81, 81 rupees basically. So I have to find principal amount. Principal amount is this much. So principal is 25 by 3 whole cube unit will be nothing but 81 into 625 into 25 upon 27, right? So this I calculate this 27 3, yeah, then 625 into 75 I calculate. This gives me 468 46875. Now if someone does not remember this formula, then we can deduce it also here. I mean, how come? Let us see. Time 1, 2 and 3. Now simple interest we know will be what? R is 25, I mean 1 by this, that is 12% of this, right? That, I mean R is 3 by 25, 3 by 25. So 3 by 25 of 25 by 3 whole cube. So that gives 25 square upon 3 square, which is 3 square. And this remains same, 625 upon 9 and 625 upon 9. Now CI. CI will be 625 upon 9. First year it remains same. Second year what will happen? Second year this will increase by 1 plus R. 1 plus R. R is 3 by 25. So that becomes, it will be 28 by 25 times of this. Right. So 625 by 9 into 28 upon 25. Why? Because this is 1 plus R. That is 1 plus 3 by 25, which is 28 by 25. Right. So 28 by 25 times 28 into 625 divided by 25 9 is 700 by 9. So this we get as 700 by 9. Then further from here we will again do the same thing, 28 by 25 to get 784 by 9, right? 784 by 9. So now we have obtained, right? So the difference we have to find. So here difference is 0, here difference is 75 by 9, and here the difference is 159 by 9. If we add this, we get, I think, 975 plus 159, which is 214 by 9, which is 26 units, same as what we have obtained here, right? So this is the process which we will have to adopt in case we forget this formula. Otherwise, with the formula, this is extremely easy to calculate, right? So this is what we have seen, certain illustrations on the relationship between SI and CI for 2 years and 3 years cases. Further cases are not expected. I mean, even the difference between the SI and CI for 3 year is not a very likely case, but that we have discussed here. What is most likely, which appears in many of the exams, is the difference between the SI and CI for 2 years. So that is pretty simple and driven by the formula, which is R square into P. So hope this was clear enough. Thanks for watching this video.